Look up at the night sky. Among the countless points of light, one gleams with a distinct reddish hue. This is Mars. It isn't the brightest object, nor the largest. For centuries, it has captured our collective imagination like no other world. Why? Because it feels attainable. It is our neighbor in the cosmic street, close enough to study and to visit. And perhaps, just perhaps, to find that we are not alone. The idea of Martians, little green men in flying saucers or microscopic life hidden beneath the soil, asks the fundamental question, is there anyone else out there? That question drove us to build ships of the imagination, and eventually, ships of metal and fire. The dream of life on Mars is woven into our culture. We imagined great canals built by a dying civilization, and desperate schemes to channel water across a desert world. We wrote epic tales of heroes and princesses on Barsoom. Those stories reveal a deep-seated hope. The universe is full of possibilities. Mars, similar to Earth in some ways, alien in others, became the perfect canvas. We feel a cosmic kinship when we look at Mars. We see a reflection of our world, or a version of what it could become. The red dot is a beacon of possibility, a constant invitation to come and see. To understand the search for life on Mars, we must first get to know the planet itself. Imagine a world that is both familiar and profoundly strange. Mars is a desert planet on a planetary scale. Its surface is a vast, cold, rusty landscape colored by iron oxide, the same compound that gives rust and blood their color. This terrain is not monotonous. It is dramatic. It hosts Olympus Mons, a shield volcano whose base could cover Arizona and whose peak rises 3 times higher than Everest. It is also home to Valles Marineris, canyon systems that dwarf our Grand Canyon, spanning the width of the United States. The Martian air is a mere ghost of Earth's atmosphere. It is about 100 times less dense and composed almost entirely of carbon dioxide. This thin blanket offers little protection from the sun and does a poor job of trapping heat. As a result, Mars is brutally cold. Equator noons may briefly reach 20 Celsius, but nights can plunge to -73. The sky is a pale, pinkish tan, yet sunsets glow an otherworldly blue. The most tantalizing feature is water, ancient deltas, winding channels, and vast outflow plains forged by floods. Geology tells us Mars was once warmer and wetter, with a thicker atmosphere, and perhaps lakes or shallow oceans. Where did the water go? Much is locked in the polar caps, a mix of water ice and frozen carbon dioxide. Vast stores may be trapped underground as permafrost, perhaps even in geothermal warmed subsurface lakes. This ghost of water, past and hidden, is the strongest reason to believe life once existed, and might still persist in protected niches. Even the simplest fossil microbe would forever change our place in the cosmos. The story began with telescopes and imagination. Schiaparelli, Lowell. They drew straight lines, canali, and the public dreamed of Martian canals. Then came Mariner. Close-ups revealed not cities, but cratered, moon-like plains, seemingly dead. The dream of intelligent Martians faded. The question became microbial. 2 Viking landers carried miniature labs to test for life. They probed Martian soil for metabolism, consuming nutrients, releasing waste. A key experiment returned a positive signal with gas release, consistent with microbes, but organics were not found. Biology or exotic soil chemistry? The debate continues. A new era begun. Follow the water with orbiters, landers, and rovers. Robotic geologists exploring ancient deltas, clays, and lake beds. They study rocks, soils, and atmosphere to reconstruct climate and habitability. Scientists act as cosmic detectives seeking biosignatures, fossils, layered structures and microshapes akin to stromatolites. Chemistry, complex organics, amino acids, and lipids, especially in ancient lake beds. Isotopes, life prefers lighter carbon. Ancient skews could be powerful hints. Atmospheric clues, reactive gases that persist, must be replenished. Rovers are mobile labs, drilling rocks, zapping targets, and reading the fingerprints of life. Piece by piece, the story emerges from ancient stones. Spirit and Opportunity were pioneers. Opportunity quickly found water-soaked rocks, spherical hematite concretions, blueberries, that on Earth form with water. Cross-bedding indicated ancient flowing water. Curiosity landed in Gale Crater, a climate history book called Mount Sharp. It drilled mudstone formed in calm lake waters. Water and key elements: sulfur, nitrogen, hydrogen, oxygen, phosphorus, carbon, signaled habitability. Curiosity made the first definitive detections of complex organics preserved for billions of years. A whisper from the rocks, hinting at life's story. Perseverance landed in Jezero, an ancient river delta ideal for biosignature hunting. It collects and caches the most promising samples for return to Earth. A future mission will bring them home for definitive tests. Methane has been detected in fleeting puffs. A thrilling, perplexing clue. On Earth, much methane is biological. Could Martian methanogens thrive underground, their gas seeping to the surface? Or geology? Water, CO2, and olivine reacting to make methane without life? Distinguishing sources demands more data, precision, and perhaps deep drilling. Other mysteries: dark seasonal streaks may be dust flows, not brines. We see unexplained oxygen spikes. Mars keeps its secrets well. The methane enigma embodies the drama of discovery. The search for life on Mars stands at a thrilling crossroads. We have journeyed from imagined canals to confirmed ancient lake beds. We have found chemical building blocks and hints of modern activity, but no final answer. Mars sample return will be our boldest step. Those cores are our best chance to solve the mystery. On Earth, we will search for microfossils, probe organics, and read isotopic signatures with unmatched precision. Bringing samples home is the logical next move. Human explorers could do in a day what rovers take a year to accomplish. With field intuition, they can target key sites, drill deep, and run complex experiments on site. A human presence would be a monumental leap toward a multi-planetary species. Such steps reshape our destiny and illuminate our place in the cosmos. This quest is scientific and deeply human, powered by curiosity and hope. Every discovery teaches us about planets, our solar system, and what makes worlds habitable. Mars shows how warm, wet worlds can become cold, dry deserts, a sobering climate lesson. The red planet still holds its secrets close, but with each mission we hear a little more of the whispers it has kept for billions of years. Come and see.